One of my favorite sections in the book, section 2.2, we talk about the graph of a function, and graphs in general show a clear relationship between variables, but the graph of a function is just a collection of points, x, y, that satisfy the equation y equals f of x. And I want you to keep those two concepts in mind, that all a graph is just a picture of all the ordered pairs that make the equation true. Okay, we're going to talk about that a lot. So when you're looking at a graph, as we've talked about, you can easily determine whether the graph is that of a function or not by whether or not the graph passes the vertical line test. And just a quick reminder of that, the first two graphs here are functions and the other two are not functions because they don't pass the vertical line test, meaning that you'd have multiple outputs for the same input. And so anyway, let's go ahead and take a look at the new stuff. Here we have again a collection of points that satisfy the equation. Okay, so again, if x, y is an ordered pair on the graph, like we have up here, 0, 4. So if 0, 4 is on the graph, that means that f of 0 is equal to 4. And remembering that what's inside the set of parentheses is always the input, okay, and many times that's an x, and then what comes out is just what we call the output. Okay, the output is also f of 0. Okay, so we can also call f of 0 the output. In this case, f of 0 is 4. Okay, and so if we're looking at this graph, we can see that when x is equal to 0, y is equal to 4. Or in this case over here, if x is equal to pi over 2, then then y is equal to 0. All right. So then over here, part A, it's asking us what are f of 0. Well, we already talked about that. F of 0 is 4. Okay. F of 3 pi over 2. If we just find 3 pi over 2 on the graph, we can see that the y coordinate is 0. And then f of 3 pi. Down here, the coordinates 3 pi comma negative 4 are on the graph, and so therefore when the input is 3 pi, the output is negative 4. Okay. Now just a quick reminder on domain and range. Domain is all the acceptable inputs, or you can think of it as all the inputs that are used to graph the function. Okay, so the domain is always going to be from left to right. All right, and the smallest x to the largest x, and we can see that clearly, hopefully, that the lowest x that we are using to graph the function is 0, and the highest x that we're using to graph the function is 4 pi. Okay. The range of f then would be from bottom to top, the lowest y to the highest y. Okay, and the lowest y, we should be able to see that as negative 4. So the range of this function is the interval, or all the real numbers I should say, from negative 4 to 4. And you can tell that just by looking at the graph. Okay. List the intercepts. Recall that these are points, if any, where the graph crosses or touches the coordinate axes. So starting with the y-intercept, we can see that the graph crosses the y-axis at let's see if we can put this in here. So the y-intercept, the graph crosses the y-axis or touches the y-axis at y equals 4. And we can just put a number, 4, that's fine. You can put y equals if you'd like. And then the x-intercept, let me write that in a different color. The x-intercepts, by the way, you can never have more than one y-intercept, right? If you have a function, because that y-axis would cross that graph at more than one spot. The x-intercepts, you can see them, you look at the graph here, it's everywhere where y is equal to 0. Okay, you can see where the graph here crosses the x-axis, and there's 4 of them. So pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. So all the odd pi's over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Okay, so those are all the x-intercepts. If this graph kept going, if the domain were all real numbers for this cosine function, then we would have an infinite number of x-intercepts. Okay, so for part E, it says how many times does the line y equals 2 intersect the graph? Well, how many times does the line y equals 2 intersect the graph? So I've got a lot of stuff written on my graph here. Let me erase some of this stuff. Okay, and get rid of that. And we're going to draw the line y equals 2. Okay, let's use this color. So if we draw the line y equals 2, we can clearly see that 1, 2, 3, 4, 4 spots on the graph is how often that line crosses the, hits the graph, intersects the graph. Part F, for what values of x does f of x equal negative 4? So you should be thinking about this question as meaning, what are the inputs when the output is negative 4? And if you know where to look, these problems are actually really easy when you know where to look. Here we have an input of 3 pi when the output is negative 4. And over here to the left, we have the input of pi when the output is negative 4. So that means for what values of x? Well, what are the inputs? The inputs are right here. The inputs are pi and also 3 pi. Okay. Oops. Sometimes you'll see stray lines. I'm trying to squeeze the screen in and maximize it and minimize it, so apologize about that. For what values of x, so finally part G, for what values of x is f of x greater than 0? So this is one of the most important questions because this really shows an understanding of how functions work and what the inputs are versus the outputs. So first of all, let's define what f of x greater than 0 means. F of x, keeping in mind, f of x represents the outputs. Okay, we can substitute y for that many times. So what we're trying to figure out here is, number one, where is y greater than 0? The values of y greater than 0, if you think of the x-axis as a, let me do this, let me erase some of this. If you think of the x-axis as, let's say, a table, okay, above the table would be greater than 0. Underneath the table would be less than 0. Or think of it as anything, a rope, above the rope, below the rope. And then, so what is greater than 0? Well, those are the y values. The y values are greater than 0 when the graph is above the x-axis. And so that's a key concept there. The graph of the function is above the x-axis, it means the values of the function are positive. When the graph of the function is below the x-axis, the values of the function are negative. Okay, and then, so, but the question is asking for what values of x is this happening? In other words, what inputs cause the outputs to be positive? Well, if we break this down into the different sections, if we look closely at the graph here, we can see that from x equals 0, I should put parentheses there, from x equals 0 to x equals pi over 2, the graph of the function is positive. Okay, these are positive. These are all positive up here. And then from the x value, or the input of 3 pi over 2, to the input of 5 pi over 2, so we have 3 pi over 2 to 5 pi over 2, the graph of the function is positive. And then also from, you can see, 7 pi over 2 all the way to 4 pi, okay, the graph of the function is positive. So it's a lot of stuff written there. Let me just write it all the way down here. So the answer for G would be the inputs from 0 to, let me look back at my graph, from 0 to pi over 2. So this is the way we write this. Also, again, from 3 pi over 2 to 5 pi over 2, 3 pi over 2 to 5 pi over 2, and then finally from 7 pi over 2 to 4 pi. Okay, 7 pi over 2 to 4 pi. I'm going to continue this lesson in the next video, so we'll see you then.